Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Hi folks, thanks for joining and welcome to the WeAreDevelopers.net Day live from our studio in Talent Garden, Vienna. My name is Sead and I will be your host this afternoon. I hope you are well, healthy and safe, and I also hope that you already got your coffee ready, because we will have 4 very interesting and intense sessions in the upcoming hours. So after the Java Day, the Containers Day, the Python Day, now we are moving ahead with talks from the .NET and C# universe. We will talk about compilers, Roslyn, Blazor, Azure Functions, serverless, and many, many more. And we will kick the day off with a session about test-driven development. If you want to actively join the discussion, please watch us from wearedevelopers.com/live and use the Q&A tool to ask your questions to the speakers. And just before we start, just 2 very quick things. First, I want to drive your attention to a very nice event run by our friends from Female Founders. It's about connecting women in tech, startups, investors, and leading corporates. You can see the details on the slide, so if you're interested, feel free to join. And secondly, I also want to drive your attention to our code of conduct. Here is a short video explaining what it means. In the meanwhile, I will get our first speaker on stage. See you soon. Okay, now it's time to introduce you to Alex from Avanade. Hello Alex, thanks for joining us. How are you today?
Sorry?
Hello, thanks for joining. How are you?
Yeah, thank you very much for having me. I'm fine, thanks. Hope you too.
Yes. Where are you joining us from?
I'm joining you from Munich, in Germany.
Yeah, how's the weather there?
Very good. Sunny.
Nice to hear,
and
nice
warm.
to hear. Cool, and tell us Alex, what will we learn from you today?
Well, I'm currently gonna present some basic concept of TDD, which is a test-driven development, and I'm going to just explain and show a little demo about how can you benefit and how you apply it in your day-to-day work.
Okay, very interesting, Alex. The stage is yours.
Oops, sorry. Hi all. Yeah, hope everyone is there. Okay, and let's continue. So we're going to talk a little bit about why you must use TDD now. But for those of you who is interested who I am, my name is Banul. I am enterprise consultant working for Avanade in ASG, and currently I reside in Munich. Well, I recently moved to Germany from St. Petersburg, Russia, and I have been with Avanade for about a year, and I'm going to tell you a little bit about Avanade just in a second. I've been actually a .NET full stack developer for 7 years, and I've been into programming since I was 14. Well, I'm extremely passionate about clean architecture, test-driven development, microservices, and I've been moving to cloud computing lately. Personally, other than everything else, I like to travel and play drums in my spare time. Okay, so we are going to talk a little bit about Avanade. Probably some of you have never heard about Avanade before, and then we are going to dive right in, and we are going to talk about test-driven development. For some of you, you are going to understand that you've done it before. For others, this is going to be a new topic. So we are going to make sure that we have covered the basics. And then we're going to dive into why test-driven development is so valuable and why you should consider using it in your project now and then. And we have a small demo where I'm going to show how you can leverage TDD in real life. And of course, finally, it will have a chance to answer your questions. Okay, so without further ado, let's start with what Avanade is. So for those of you who don't know, Avanade is an enterprise consulting firm. Well, everybody probably heard of Accenture or PricewaterhouseCoopers or Deloitte. We are just like them, but we have a focus on Microsoft and the Microsoft ecosystem. Imagine if 20 years ago, Accenture and Microsoft decided to have a baby that would be Avanade, because Avanade is actually a joint venture between Microsoft and Accenture, and we are actually become the Microsoft consulting arm of Accenture. So we work directly with Accenture, we work directly with Microsoft, and of course, we work directly with our clients. And like I said, we've been doing that for about 20 years. So, and I'm going to give a definition of TDD in a moment, but let's talk a little bit first about how traditionally we approach our development cycles. So let's assume that you have a Scrum or Agile backlog, which is filled with a bunch of stories. You define what is going to get developed, and you must get into implementation phase. So you have a user story. Okay, for example, create sign-in button, which leads to the sign-in page. And you must implement the scenario. For example, scenario number 1. As a login user, I want to be able to click on the sign-in button, and I must be redirected to the sign-in page. And then you have scenario number 2, scenario number 3, scenario number 4, and so on, so on. And each and every single one of this scenario has acceptance criteria and has things that you're supposed to do from the business standpoint. Well, after all the implementation is done, and you are so at an organization or in a project which requires you to have tests, then the next step is that you will start to cover everything with everything which you have implemented with tests. So at least you should have unit test coverage as bare minimum, and that could be run on the CI/CD pipeline, for example. And if you're lucky, you have integration tests and acceptance test. In really rare cases, you might even have the UI test, which is Selenium, for example, and the different types of like regression tests. Well, and the challenge you have in the end of the day, you have implemented a whole bunch of stories and so the problem is how without human effort to test everything, you can be sure that you have succeeded. And how do you know that the code is following every single path of the requirements without having to get you to dig in deeper? And this is the challenge we all constantly have. And in order to avoid the situation when QA returns you back the user story because they find some issue, or even worse, the situation when QA doesn't run the complete set of tests or they missed something, and then it gets all the way to the production before you find out that the critical requirement was missing because like it went through the QA and through the UAT, and then, well, in the production, somebody realized that sign in button doesn't work because you have some broken logic which has slipped from QA and the UAT. And yeah, with this kind of situation, yeah, we are handling. So there, where is TDD come into play? So what is the TDD? The TDD is a test-driven development. So the acronym for that. And if we go to Wikipedia, there said that the TDD is a software development process relying on the software requirement being converted to the test cases before software is fully developed, and tracking all software development by repeatedly testing the software against all the test cases. Well, long story short, and the idea behind is that we basically write a test and then write enough code for test to pass. Well, it seems a very simple implementation, but let's dive in a moment. Well, I'm going, and we about right now to jump into code and see this in action. But before, I'm going to talk about the core concept of the TDD, and it is called red-green refactor. So in this concept, this concept is how you define your tests. The idea is that you don't write a test for what is already there, but rather you define a test for the requirements for required functionality beforehand. And thereby you are documenting necessary requirements for the future implementation in code. Then you are getting sure that the implementation is working. Isn't working, because, well, obviously it hasn't been implemented yet, and therefore requirements hasn't been met yet. So next, you're writing just enough code to pass this test. And the idea behind that is that you're not writing code for the sake of code. You're writing enough code you're just writing enough code to meet previously defined requirements. Well, and at the very end comes refactor. After you have verified that requirements has been met and the implemented feature is now working, now it is time for some cleanup and optimization. Maybe from the first sight, it may be not so obvious that you need to treat your test code the same as a production code. Well, but it is very important. And yeah, oftenly this last step, refactor, is being forgotten or ignored. But hey, this concept called red-green refactor rather just red-green. So yeah, this step is very important as the other two. Okay, and now that being defined, let's take a look in this in action. Let's implement a simple web API calculator project. Yes, and let's just start with it. Okay, hope you can see everything. So let's assume that, yeah, we have the standard some sort of feature, and the business come to us and say that, well, we need to implement the web API calculator, which just do the addition. So we have a feature, for example, as a user, I want to have an add endpoint, and so that I could add two numbers. And then we have two scenarios, the happy flow and the edge case. Okay, and how exactly could previously we would approach this kind of task? As I said previously, we just dive in right into the code. We will implement the server. We will just implement all this implementation, and then start covering with the test. But let's do it in the other way. Let's start with the TDD. And with TDD, we need to go with the test first. But what we are going to test, we don't have anything right now. We only like have right now, as you can see, we have only the pros project, test project, and that's all. Well, let's think about that. What do we need at first? Well, of course, we need the server, and we need to be sure that this server is accessible. Well, let's implement that. So let's write a test for this case. So let's call it, for example, health controller. And by the way, I am going to, oh, I have a typo here. I'm going to come to controller test. Okay. I'm going to use this .NET 5 framework and just the ASP.NET application. So let's create a test and say that the get, for example, should return okay. And by OK, I mean that it should return 200. I'm going to use this approach called AAA, which is arrange act assert. So it will just clearly, with this approach, we can clearly see what is happening. So where we're arranging our code, where we are doing some action, and where we do the assertion. So let's start with arranging. ASP.NET allows us very neat feature, which is help us to test our ASP.NET web application. This class called Web Application Factory, and the only generic parameter which we need to pass is just startup, which is basically the wrapper with all the settings which we have in our for our web server. Well, we have a client, then by using this factory, we have a client which will later be used to access our web service. So let's do that. Let's write that we need to get a sync. Let's assume that we have some sort of health endpoint where we can check that whether our service is accessible and alive. Okay, let's use this one. And of course, we will need the response here. Oops. Okay, and now with that, let's just assert that our response code, status code, is equal to response HTTP status code, yes, sorry, HTTP status code, okay, so which is 200. Yeah, so now we have a test, but this test wouldn't compile because we don't have the startup class. So let's create, like, in order to make this test be able to build, let's create the project. Like, let's create the simple ASP.NET Core web application, which let's call it calculator.web API. Okay, and it will be just empty. Okay, let's see. And now we can see this basically this is just regular ASP.NET Core web application. We don't have anything here, so it's clear. So let's add here the implementation, the reference. Okay, now everything should be built. Okay, let's start the test. And let's give it a second. Okay, and now we are in the first phase, which is called red. Now we clearly can see that, well, our expected behavior and the expected result should be okay, but we had not found. Well, this is obvious because we haven't implemented anything yet. So let's fix that. Let's create the controller and call it health controller. Okay, I will use here the shortcut. In order to save some time. So here you can see that, you have a regular ASP.NET controller, just regular one with some routing, with like action, get, okay, and it returns okay. So probably we have implemented everything what we needed here. And looks fine to me. Let's run the test one more time. Weird. So we still have not found. And why is that? Okay, and the reason is because we haven't adjusted our infrastructure yet. So we haven't configured our configuration wrapper properly. And this is like already showing us how the TDDs work for us. Even though when you're thinking that you have implemented something and yeah, the implementations looks fine. And but there is some sort of issues there. So let's me just set controls here. We already can see that it's not working. It doesn't implement our requirements. And let's also configure CI/CD here. Add controllers. Okay. And now let's try to build one more time and see if now it's working. Okay, and now it succeeded. So we have moved from the green phase to the, from the red phase, we have moved to the green phase. And now everything is working and we implemented our first requirement, even though it wasn't here in the future, but well, it's like a normal requirement that we need to have our server. So next, let's implement the scenario number 1, this happy flow. So what this says that as a user, so happy flow, when user sends a GET request to the /add endpoint and query parameters a equal x and b equal y, whereas x and y are both integers, then user should receive a response 200 with the x plus y as a content. Okay, fair enough. Let's implement this, and as usual, we will start with the test first. Okay, let's create, and we call it calculator controller tests, and we implement the test. So let's call it get add should return correct result. Okay, let's import necessary usings. And now let's do again this range act assert. I will using the same approach here. So we have a client here. And then we need to this client to get request. Then we need to remember, where do we need to do it? So we need to do it to the /add. Okay. So it will be our endpoint, and then just provide the regular one. So A will equal 1, some dummy data, and B will equal also to 1. Okay, we need to await that. And then we will have a response here. Okay, so our requirements clearly say that we should receive a response 200. Okay, let's implement this assertion. Assert that response status code is equal to HTTP status code. Okay. Okay, and now we need to get the content from this response. Let's do that also. Response content. Let's read everything as a string. Okay, we need to await it also. Then we have a string content. And let's parse our int content as and now we need to assert that our actual value, which we await, is equal to, in our case, it will be 2, because yeah, we definitely passing the parameter number 1 and parameter number, 1 and 1. So, okay, let's try and run this test here. Let's see that it turned into the red one. Oh, yes, and we can see that, yeah, definitely we have, we expected okay, so this endpoint, this action will be accessible, but we have received the not found. So with that, let's first, what we need to do, just needs to implement this endpoint. And let's start with that. Let's create the calculator controller. I will also use here the shortcut in order to save some time. So here we can see that, well, basically we have a normal ASP.NET controller, with the configured routing, and we have our add endpoint, which returns OK. And now let's remember the part when I'm saying that you need to implement just enough code to test in order to test to pass. So let's do, you can say some so-called cheating here and just return 2. So with that, we could like do and run our test one more time. I need to rerun it manually. And now we can see that our test has passed. So we just await here that we received, and of course our endpoint is now reachable, and the value which is returned is equal to 2. But we clearly can see that the implementation here in the calculator controller is wrong. And well, how can we avoid this kind of situation? Let's go to this test and then just switch it from the test into the test case in order to provide a little bit more of an input. And let's just, for the sake to be sure that we are doing everything correctly, let's call this like a little bit of refactoring here. We just provide the A, and we provide the B, and we provide the actual expected result. Okay, so now we need to adjust our URL here, and that will be A, and this will be B. And here we just assert with the expected value. Okay, let's run it one more time just to make sure that everything is working and we haven't break anything. Cool, yes. So now it is working and we can clearly see that everything is fine. Now let's provide a little bit different set of data. For example, 1 plus 2 is equal 3. And okay, let's see if it's work or not. And now we can see, yes, now it's not working. So let's go back and fix that issue. So we need to go here to this controller here. And well, now we definitely need to provide the correct implementation. So let's do that. So let's do index and y, and then return x plus y. And now we will run the tests. Oh, and now both are failing. What seems to be the problem? Okay, so the thing is that we have messed up with the parameters here, because in the feature it's clearly said that we need to A be equal to X and B equal to Y. But here we have X and Y, so the framework cannot like fetch the correct value, and therefore returns us invalid values. Yes, and let's just fix that. And here it is A, and here is a B. Okay, now let's run the test one more time. And now we can see that both of them are passing. And you already can see that it is easy to do some sort of like typo here. And well, basically it's work as it should, but like slightly different with it should, not according to the requirements. And already we can see that how this is helping us in our work. Okay, and let's just to be 100% sure, let's just add -2, and this should be equal -1 to see that everything is working as it should. Okay, and now we can see that everything is working. And with that here, we have finished with the implementation of our feature 1. And we already seen that there is like a lot of the way where can we fail, but how can we bypass that with by using the TDD and the test approach first. So I think that we're probably right now a little bit short in the time, but I have this example fully finished in my GitHub, and I will provide the link a little bit later. There you can see and follow all the commits. Through the commits, you can follow the logic and see how exactly I have implemented scenario number 2 here. And so with all this edge case 1, this, the spoiler, it will be also interesting because there's even more refactor, and it will interesting the standpoint of view that how can TDD works in this case. Okay, so let's go to the presentation. So yes, as I said, the code is accessible on my GitHub, and the name for this repository is calculator TDD. Feel free to have a look, and we can talk about that afterwards. So so now let's just talk about, like, summarize what we have seen and what we went through. So what is the pros and cons of the TDD? So the biggest pros of the TDD is that you have the testable solution, because, well, you basically starting from what is the most important. You're starting from implementing the test, and then you're just keeping in mind that everything should be testable. And in the end, you have a testable solution. Since you have a testable solution, you will have a cleaner architecture, because, well, in order to achieve this testable architecture, you will have to provide more more abstractions, more like using some sort of pattern, and therefore you can, it will be more testable, and you will have to use some sort of patterns and maybe mock some things, and with this abstraction you can achieve this more easily. Well, it also reduced the costs and low to the QA, because previously, if you haven't been able to test it by your own as a developer with automating tests, because and then you send everything to QA, then QA just tests it and then saying, well, something went wrong, and sends you this user story you're back, and the cycles going and on and on and on, and it's really time consuming. But with this approach, you be able to be sure that everything which you send is like bulletproof to the QA, and like returning the user story is an exceptional situation, will be exceptional situation in this case. Well, and in the end, you will have a happy client. You will have, like, if you don't have a client, and a manager, like product owner, and also, we need to speak about a little bit of cons. And the main con is that it requires a time and self-discipline to adapt this this approach. The thing is, it's always you will have always this temptation to do the implementation first, and only then just like, okay, I will do this testing afterwards. I will do this after, this like, I will do 1-2 unit tests and something like that. But we all know this is lie, because afterwards, later, there will be some new issues, some new feature which you need to do, and it won't be implemented. Well, maybe you will be lucky and you will implement it in the end, but let's face it, you probably will forget about it, and this case won't be covered. And you, of course, need to sell this approach to the team, to the manager, to the client. You need to convince and make them understand that it's necessary to, if you care about your if your project is well enough tested and secure and bulletproof, then you will need to adapt this. And even though you can see that and you can feel that it has a little bit more effort on the start, it will save you time in the long run. Well, with that, there are some links. Let's stay in touch. If you have any questions, if you have something you want to ask me and talk about the TDD and everything else, There is a Twitter link, there is the GitHub, there is also where you can find this full second scenario of the full test project, and LinkedIn, yeah. And with that, yes, I'm also, and I'm feel free to your questions.
Okay, thank you very much, Alex. Thank you for the overview. And we already have quite a lot of questions. So I would say that we just jump right into the questions and I start. So let me see before we start. Yeah, let's start with a simple one. Also asked from Alex, what IDE are you using for the demo?
Yeah, I'm using JetBrains Rider IDE for this demo and for my main work. I just like it. It's useful, and the Git plugin is like Uber feature for me.
Yeah, I think it's very popular, right? So many people use it.
Yeah.
Yeah, so then an interesting question from Gregor. He is asking, how do you make sure to not over-engineer the test? So when do you know that it's enough?
Yeah, good question, Gregor. The thing is that you need to, because this is like the question a little bit as a near. So this question is like very not directly to the TDD, but for the testing itself, for the automation testing itself. But well, you need to have your test as more understandable as the smallest as possible, in order just to see that in order for other developers to be able to maintain it. So the thing is that if you see that your test is like for 100 lines of code or 200 lines of course it is already bad and over-engineered, then you probably need to consider, and probably you need to think about that something is not quite right in your architecture, because if you have your architecture correctly built, then it shouldn't be so it shouldn't be quite hard for you to test it, because you have covered everything with abstractions, and then you just need to isolate this abstraction and then cover exactly it with tests. Yeah.
Okay, thank you very much. So let's see what goes next. Alexandra is asking, is it good practice to have 2 asserts in one test? Because I think in the example you use 2 asserts in one test.
Well, I would say this is probably the who likes what. So basically, you could split. Of course, you could split those twos into the 2 unit tests where you're just testing that your controller returns you 200 or whatever it returns, and then the other one which returns you the correct content. But still, until it is readable, until everyone can maintain it, and you're not like messing around what the hell is happening here, and how exactly can I understand what happening in the test, I think it's fine. So of course, if you have like 100 assertion in one test, then it's probably wrong. But if you have like 1, 2, then it's probably fine.
Okay, fair enough. Then the next question from Roberta. Does the same person writing the test also writes the code in general, or usually 2 different people do it?
Person writing the test. Well, it's very depends on your organization where you're working. Some of organizations have the different set of developers who are writing acceptance criteria or acceptance tests. But basically, if you're writing the unit tests, then I would say yes, it's your responsibility to write unit tests for what you have implemented, like in the vice versa, like writing the unit test for what you are going to implement. And but if you are saying about the whole picture about the acceptance test, if you're lucky and you have a special team for that, then sure, they could write it. But oftenly, you are the one developer who should be responsible for your testing. And well, the thing is that you need to be sure that you have implemented everything. well, you need to be sure that you're providing the QA or the product owner or whoever the correct implementation in this case. So how can you be sure if you like not cover everything with the test, for example, with automated tests? So it's a question for yourself. Are you 100% sure that you are providing the secure test, secure solution? If yes, okay. If you need some other test, just write it.
Okay, another question from Roberta. It's a very interesting one because it's also a statement. Hey, don't people sometimes write their code to satisfy their tests rather than writing code to build their product? So maybe you have an advice also how to, trust yourself and don't lie to yourself when writing the tests.
Well, the thing is, as I said, that if you have a the standard approach is easily to go to the where you need to write a test for the sake of test. So where you only your main concern is to have the correct coverage. And in a lot of companies, like the coverage is like the number which is like, well, we have 80% of coverage. Now we are totally cool with it. Yeah, we are super duper. But with a TDD, the main concern and the main topic is that you are providing test only for the feature and so beforehand. So you are just defining the requirements in test in order to you to be not to forget something and to be sure that this feature is implemented, and then use it as regression afterwards. Yeah, that's when you just refactor the code that these requirements has been met and nothing has been broken.
Okay, thanks for that. Pavel is asking, how do you convince managers and team leads to use TDD while it seems to cost more time at the beginning and is beneficial after a rather long time?
Yes, really good question. Thank you, Pavel. But I will say that, first of all, we all are professionals. And we know that how we need to write the code. And the managers, basically what their interest most of all is that when it will be done and how fast it will be done and if it will be done. And if you go to your manager and saying that, well, I as a professional, I think that it will be implemented. I need some X day, like 10 days for implementing that. And I can guarantee you 100% that it will be implemented in this time. You should do so. And saying that, well, how can you convince the manager? Well, you need to probably provide some sort of proofs and like say that it will, maybe it will get a little bit slower, but in the end, we will go more secure and our code will be bulletproof with this kind of technique. So you need to say that, well, as a professional, I know what I'm doing, and I want to provide the client or the product owner only the 100% good product without like going on and on with like bugs and so on. So like providing the product and the client said like, well, it's hell of a lot of bugs and so on. And then you fix it and then you have the bad relationship with the client, and so you need to like I hope I give you some clues.
Maybe also just to let the managers watch this video.
Maybe.
Good work. Matthias has a nice question. What about fetching from external services like DB, like a database? Do you mock it or test against the DB?
Well, both, I would say. So it really depends on what exactly are you testing. So of course, if you like implementing, like you're working and adopting, you have adopted the clean architecture pattern and like behavior, then you will probably have the separate like repository, or you have a separate interface for you to talk with your database, and therefore you could mock it, of course. But with that, you will test the logic which relies. Well, you only test mocking. You will only test logic which doesn't rely on the data from the database, and you can mock it whenever you need to do the unit test. But if you want to do like the overall testing, more like integration testing or the acceptance criteria, then you can have like the end-to-end testing with your database is used. It also like everything depends on what exactly you want to test and how you want to test it. So and if you need that to be 100% sure that everything is working, then you need to also provide the test which will go from the client, from the endpoint up to database and backwards.
Okay, then let's see what question goes next. Konstantin has a simple question. Which technology stack do you usually use?
Well, as I said, I am the .NET developer, so I'm using using .NET stack. So it's I'm using some sort of IRM, micro ORM, so NT framework, Dapper.NET, and then .NET, and then usually we use the SQL Server. So everything which is related to the Microsoft, I would say.
Tommaso has a question, or it's more like a statement. He says he would like to see more real cases. It's easy to create tests for a calculator with specific endpoints. Real applications rarely have separate logic for each function. Maybe you could give some advice, like how where we can find deeper references or.
Well, there is probably I will need to do. You can, definitely reach me on Twitter or anywhere. I could provide you with some of the links to it. But how, referencing to your first question, how to work with some sort of legacy application or already bigger application. The thing is that probably the advice will be go to with some sort of bigger test where you have input data, output data, when you can cover the huge things, and then you need to consider splitting it to the more testable chunks where you need to provide some abstractions in it, where you need to provide some interchangeable things, and then you can cover it with unit tests, but of course, you will need to go with the test first. So you need to think about architecture and how your product is built beforehand. While you were thinking beforehand, you will need to keep in mind that how you need to build your architecture in that way that it could be testable. And therefore DDD is very useful.
Okay, then there is also a maybe connected and interesting question from Miss or Mr. Anonymous with the question: as we are working in Agile and the requirements change frequently, how should we manage TDD?
Maybe I haven't fully understand the question, but the thing is that basically in TDD, while you're using TDD, all your test is basically all your requirements. Most of all, and if the changes can be changed, then you go and change these requirements in the test, and then you're getting sure that everything is working. So probably it's not so different from the standard approach, because whenever your requirements has been changed, then you need to go to the code and then adjust it. But with TDD, it's pretty much the same, just you starting with adjusting the test and then see that now your new requirements are not implemented, and then implement them and then refactor in order to work smoothly.
Okay, thanks. Then Balázs has a question. How are tests in production connected to a monitoring system so you get notified if something goes wrong?
Well, I would think this is the question about the CI/CD more or less. So you will probably have your continuous integration tool such as Jenkins or Azure DevOps or JetBrains, TeamCity, whatever you more prefer. Then there you will have a build pipeline where you will say that, well, we need to run some set of tests, maybe some regression tests which could run overnight, and then if something happened, you will instantly receive the message, and then you will go one morning when you start working, you will see that, well, we have some problems, and you start to investigate and fix it.
Okay, then Rock is asking, how do you unit test parts of the code which include a third-party SDK, for example, payment processors?
Well, You probably should have, as I said, you should have some sort of abstraction which is communicating with this third party, service, and then you can easily mock it. So then you will test your logic based on the mocked response from this test, from this third party, some sort of third party service.
Oh.
I would go with that direction.
Yeah, okay. And then there is only one question left. So what are the limits? What can you not test?
I don't want to say that there is nothing you can test, but sometimes, yeah, there is some issues which is like more testable, some was less testable. But I would say that probably right now every framework allows you to have the almost 100% testable solution right now. And the only thing is that how you approach for that, for how you approach to build it and develop it. So if you will be thinking about that, that you need to have the testing solution and everything could be testable in the first place, then you will have it in the end.
Okay, perfect. That was the last question, Alex. Thank you so much for your presentation, and also thanks for taking the time to answer all the questions. It was quite a lot of questions, so it's also a signal that that the talk was very interesting. I hope that we can have you again as a speaker in the future, maybe also on some other topics. So looking forward to that. And basically now we have a short break of 10 minutes. We will start at 2 p.m. sharp with, that's a nice word, joke, like we will start with building a compiler with C# with Florian. So take the time to grab a coffee and see you in a couple of minutes again. Bye-bye.
Bye.
Okay, hello everyone, welcome back and thanks for staying in the stream. So I am here with Florian, our next speaker, who will talk about building a compiler with C#. Looking very much forward to that. Florian, hi, thanks for joining us. How are you today?
I'm fine, thanks.
Cool. Where are you joining us from?
I'm joining from Munich, Germany.
Oh, also Munich, so the second one from Munich today. That's very nice. So I will not ask about the weather. It was nice. That's what we learned. I hope it was not a lie.
No, I mean, it's from what I see, it looks good.
Perfectly. Tell us, Florian, what will we learn from you today?
Today we will look a little bit into how a compiler works and what we can do in C# to actually build one ourselves, or at least build, let's say, a more sophisticated parser.
Okay, perfect. Florian, the stage is yours.
Thanks.
So, Florian, du kannst dein Bildschirm teilen, bitte. Und du bist live in.
Hello, everyone. So let's jump right into the topic, building a compiler with C#. What I will use to motivate this topic and to illustrate some of the concepts I will present here is a project called Mages, which is, well, already, I would say, in today's age, quite old. I think I started that like 4 years ago. And it was, let's say, from an evolutionary point of view, I think the third iteration of building a compiler and a virtual machine also in C#. And I think the code there was quite, let's say, refined up to a point where it's quite digestible and very well to read. So let's jump right into the topic. My name is Florian Rappl. I'm a solution architect at a smaller company called smapiot. We're doing a variety of things, mostly in the digital transformation space. Right now, I'm mostly concerned with things in IoT and embedded computing. I do microservices using .NET Core, and I'm one of the advocates of a new pattern called micro frontends. I'm laughing there a bit because, I mean, this thing is still, let's say, on the rise, and you may or may not have heard about it. You may hear about it this year. If not, I'm certain you will have heard about it more by the end of next year. In this space, I'm also currently writing a book, which will be released, I think, in, let's see, July or August. And yeah, writing is one of the things I like to do, let's say, in my spare time. I'm a Microsoft MVP for development tools, and I like to contribute to open source projects like the one we will see in a bit. But first, let's reflect a bit. I mean, it's now really some time ago. It feels quite long ago already, when at Build 2015, there was the grand, let's say, launch of Microsoft's new compiler platform, which was codenamed Roslyn back then. And here you see a picture of, Mats Torgersen and Dustin Campbell. Both are really famous within the C# community because, of course, they're driving forward not only Roslyn, but C# as a language, and also other .NET languages. So Visual Basic was also one of these childs. Now, of course, no longer there. And I think the focus is more and more shifting towards F# for that purpose. But let's not discuss languages at this point. Let's maybe have a look at, let's say, what Roslyn offers. I mean, if you use C#, you use Roslyn all the time, right? Because Roslyn is the engine that gives Visual Studio all the information about your code that you're writing. And the reason for that is that Roslyn is a little bit more than that's just a compiler black box that takes source files and spits out some .NET assemblies. What Roslyn brings to the table is a whole set of language services that can be used by a system like an IDE, like Visual Studio. So it gives Visual Studio all the APIs to get information about the code you're writing. For instance, what kind of references are associated with that symbol. There are other things that you can do using Roslyn, right? It has instant support for a so-called Rappl, a read eval print loop. We will see one in a couple of minutes. And it brings even support for, some kind of metaprogramming that you want to make on top of it. So all in all, it opens this black box of the compiler and it shifts out all these APIs and makes them accessible. And that was one of the reasons also why Roslyn was brought in the first place. Beforehand, the C# compiler was written in C++. It was hard to maintain, and integrating it in Visual Studio was a cumbersome job. Now, the API of Roslyn is, well, quite detailed, I would say. It's actually well designed, and it brings all these capabilities that I just mentioned to an application level. So it does not only bring, let's say, elementary things like a lookup where the references go, but even refactorings and things like colorizing and all that. That's all part of Roslyn, right? So even things that you say, well, that's job of the IDE, but that's also part of Roslyn's API. At the end of the day, the thinking here was quite simple. The thinking was, what if we could just, let's say, package that all up in one project, I mean, the compiler platform essentially, and then multiple IDEs, not only Visual Studio, can leverage that. And interestingly enough, I mean, that really provided the basis for quite cool projects that in the end then turned out to be a completely new specification, for instance. So you may have heard of something called the Language Server Protocol. And that little thing that is one of the drivers of, let's say, language integrations in IDEs such as Visual Studio Code, that was actually created initially by Roslyn, right? So they created a little bridge, a little project called OmniSharp, and that had more or less the first version of this LSP, the Language Server Protocol. So quite cool. So this whole concept of really bringing IDE-grade support within the compiler API already, I mean, the thinking there was not new, but doing it on the scale of a popularity of a language like C#, that was new. And I think the experiment was, as we know today, quite successful, right? So all of these things are just there. Now, if you want to leverage that, a very simple thing that you can do is you can use a tool like I prefer to use, LinkPad, you may know it. And that also, of course, runs against, well, Roslyn under the hood, right? And it does that to, well, transpile your C# code to a variety of targets, usually, of course, directly compiled to the intermediate language. So if we zoom in here a bit, you see that my simple code here with the 2+3, and then I just dump it to get the result, is represented here in the intermediate language. You may have seen that or not, but that's at the end of the day what is, let's say, part of, or the main part of your libraries, right? And that's what's interpreted then by the core language runtime. So the thing that makes .NET run on any platform, so to speak. Right, and the thing even goes a little bit further. So we can get the intermediate language. Well, that doesn't have something to do with Roslyn directly. We could have gotten that beforehand, but we also get the tree information from our source code here. So we can just in the simple IDE mark something. And if we then zoom down, we see that's a parenthesized expression. It's actually an add expression. And here you see what it does. It has these numeric literals, it has 2 and 3, and it even stores some white space trivia in there. So all of that information is somewhat preserved by Roslyn or by the compiler. So here that's more, let's say, the parser view, but we'll focus on that first. Right. Great. So let's move on there, and let's jump into the topic of majors that I initially mentioned. I first want to show you a bit why that came up, right? So here I have a little animation of a game called Sign Rider, and I think it was quite a cool or funny idea. And essentially, what the game was about is that you get a kind of a mathematical described curve. And this curve needs to be, let's say, driven by here the characters in this sledge. And the goal of this game was essentially to, well, let them ride this this slide or whatever you want to call it the longest, right? So you see here that the time, and of course, if you have, let's say, more or less a hole like that or a local minima, they will potentially end up there and the ride is stopped. And these curves there, well, I mean, you've seen maybe already now the formula below there. They can be described, quite complicated. So at the end of the day, what you need for such a game is a direct evaluation of this equation that the user can enter. And then you need at each point in space or in time, depending on your variables there, to evaluate that. Simple as that, but how do you get now this parser for this mathematical expression, right? So the authors of that game, they used C# actually to write the game, and they used an open source project. And actually there was an open source project that I created. It is not majors, but anyway. And the reason why they used it was, well, they used the Unity game engine, and not many other projects that did similar things with mathematical expressions were able to handle that on the constraints of the Unity platform. So the authors of that game then got, let's say, as it often happens, an opportunity, right? So why not making, why really stop at 2D when you can make something larger and something, let's say, more fun than just having a single slope that you can define? What if you can create a whole world like Minecraft, for instance, but instead of going around with a hammer, you describe each object in this game with a mathematical formula? And the result, I mean, this is one of the demos that they had, looks like this. So here you have a couple of blocks, and then you enter some new shape, and you describe it now with this function that you've seen. You could change that function, it would change the shape. And you can play around with every object here. So quite a sophisticated game, and I think I've seen more, let's say, advanced demos of them. Really a fun and cool project, but certainly nothing for just a lazy afternoon. You really need to think about how you, let's say, define your different objects there, what kind of functions you give them. But once you have them interacting, etc., I mean, this is a lot of fun and really, something to satisfy the nerd in you, so to speak. And of course, they again needed an engine to pass the mathematical expressions. The only constraint they had for this game was the engine needed to be much faster than beforehand. So really, we are talking here at least 2 magnitudes faster than the one they used beforehand. So we needed to write something new. And you can, of course, always ask the question, why come up with a new language? At the end of the day, I mean, we have all these languages, and I'm sorry if you can't read these cartoons. I mean, it's a classic there. Maybe I'll show this on my Twitter account later on. So you can bash any language. So for instance, for Python, it's often so easy that you just import something. And so here, the teacher says, well, this is plagiarism. You can't just say import essay. So if that's your whole essay, that is not sufficient, right? Or for instance, for C, the teacher says, this is great, but you forgot to add a null terminator. Now I'm just reading garbage. So C is a really picky language, not only in syntax, but especially regarding your pointer semantics. And if you just forget a simple thing like in a string, a null terminator, then you are pretty much done, right? So it's unforgiving. But so you can have something about any language, and this is not only programming languages, right? So it goes even down to some markup like HTML, and quite interesting. And that brings me now to what is then Magas about. So it should be a language that, well, I mean, doesn't feel exotic at all. It should be a language that feels quite direct. it should be a language that feels, well, very much familiar. And here is just an excerpt of, well, a specification of a language. So when you want to create a language, or when you also want to implement an existing language, then what you need at hand is a specification. And usually the grammar looks a little bit like what I've shown on the screen, right? So you usually have a combination of then language symbols, like you say, oh, this is, by the way, how a comparison operator looks like, with then special characters or special indicators for certain things. Like, for instance, here you indicate, okay, there is one character that needs to be literally coming, that's the greater than symbol, for instance. Or if you see, like here, a star, then of course that means there can be some of these, and yeah, as you know already from regular expressions, there may be in, let's say, infinite amount of them. So we don't know. So 0 to n pretty much. Likewise, we have, of course, something like plus, which means at least 1, or we have a question mark, which means 0 or 1, and so on and so forth. But that kind of formalism you will need, because on the one hand, of course, this is how you will implement your language. But on the other hand, if you want to implement an existing language, let's say C#, for instance, then you also will need to know exactly how this thing is defined, because this is the rules. These are the rules that, well, you want at the end of the day to have embedded in your language, right? Okay. So now you specified your language, you have all that. Let's say it's a fine thing. You're quite satisfied. You want to. You maybe already have written one application. You cannot compile it yet, but you say this looks fine. That looks like I want it to look, right? So how do you now come up with a compiler? Well, first of all, what is a compiler, right? A compiler, well, has an easy job, like our Domo here. It pretty much just transforms existing source code, which is, let's say, written in a language understandable by the compiler, to a language understood by a computer. So classically, you have an architecture, I don't know, for, let's say, Intel CPU, an x86 architecture, and you just say, okay, with the instruction set that's available here, yeah, I want to have my application. There is a little bit more to it, right? So to really have an executable, you need to consider still the operating system and things like that. But at the end of the day, that's what the compiler should do. Really, it should produce this this file that can then be understood by the computer. So you go from one representation that's understandable by the compiler, so maybe not necessarily by the human, and many languages really do a lot that they are not really well understandable by human, and bring them over to be understood by the computer. And in some cases, even understood very efficiently by the computer, so that your instructions really use the least amount of computing time. So then it's a good compiler if you can do that. And that's the end of the story. So there are multiple kinds of compilers, but most work, like for instance, in the C++ example, you have all your initial stages where you say, okay, first I walk over my files, I do a little bit of analyzing, I create a tree, I create a list of instructions, I create some outgoing code, usually these object files, and then they may be linked together with external libraries. And that's then your result, right? As simple as that. So the compiler handles pretty much all of the things that are there in the blue chain. The rest is, in case at least of C++, done by a linker. But still, the output, the object files, they come from the compiler. Now, thinking of, let's say, Roslyn or C# as a compiler, that looks a little bit different, but still, the blue boxes, very much the same. At the end of the day, you're not getting out these object files. What you get out there is this MSIL, or bytecode, in case, for instance, if you look at Java. And this is then interpreted by, well, some other application that then, well, introduces a certain kind of platform independence, because only the interpreter needs to know the target platform. Your outcome, well, that's platform independent, which is quite cool. And therefore, these kind of VMs, and we will come later on what is a virtual machine in this case, they are quite popular, and you get a lot of them, right? So some are down to a level where, say, you always start at the interpretation level, like Python, for instance, or JavaScript is also a good example here. If you think of Node.js or even running in the browser, then some require this intermediate compilation step. So for instance, Java or C#. And at the end of the day, I mean, it's all about just gaining a little bit of platform independence, but sacrificing, therefore, let's say, a little bit of a slower startup. Okay. Now, I said initially that we will learn something about compilers, but we will most focus about the parsing aspect of it. And to keep it straight, I mean, parsing is presumably the most important part of a compiler, even though, of course, especially C++ purists will tell you, no, the parser is just, let's say, it's the front end. It's not the most important part. The most important part is to generate really efficient code. And truthfully, most of, let's say, the hard work will go in this code generation. But we will not focus on this. We will not try to get, let's say, the fastest compiler out there, but just something that works. And for that, let's say we can forget about the second part and really focus on the parsing. And that also goes in some stages. So what we'll start with is stream processing. Now, stream processing deals about some incoming stream of bytes and decoding that into a known representation. So let's say you read your program from a file. I don't know, it's stored in UTF-8. And what you will do is you will take UTF-8, you will decode it to a known representation. It may be UTF-16 if you're thinking about .NET strings. But you may also choose another thing like already UTF-32. So choosing pretty much integers, always 4 bytes fixed. And you want to have this, to have it normalized, that all your next stages know, oh, okay, I can work with these kind of characters. I don't have to deal now with special decoding issues. So this also takes, let's say, some pre-processing into consideration. So you may, for instance, in case of special characters, also fill in, let's say, replacement characters, etc. All of that happens in stage 1. But once you hand over these characters, you enter stage 2, and that's the so-called tokenization. So tokenization tries to understand these characters and tries to build minimum blocks containing these characters. And a minimum block in a programming language can be something like, oh, we have a number literal value here. So 2.34, whatever. Or we have a string literal here. So here's your string literal. We've identified that the character was a quote. So we take all the incoming characters, put that in that string literal token, and we are done. Or, well, we didn't recognize any kind of special token, and this thing says while, it may be a keyword. So let's just make a keyword or a general identifier, right? And later on, we will see what it is. So this is the tokenization phase. It doesn't know any semantics about the language. It doesn't know what, for instance, a while could do or what a do could do or whatever. It only knows certain rules about these little blocks that are there. But then these little blocks are handed over to the third stage. And that's the so-called abstract syntax tree generation. And for that, now we need to know about these keywords, what, for instance, a while would mean in our language, or if, for instance, this number literal that we had in combination with an operand, I don't know, a plus, forms another kind of expression. So all of these enter the number 3. And then based on number 3, we get this output, we get this tree, and this tree can then be checked. So for instance, we could check that when we have a while statement, that the check that is, let's say, in C#, for instance, within the parentheses, actually results in a Boolean value, or if there is actually a value for it, right? That we don't allow just an empty value there, for instance. So we could do certain checks to prevent that. And depending on the language, these semantic checks are rather strict or rather open. So for instance, in a language like JavaScript, already on the tokenization level and then the abstract syntax tree generation, we are quite relaxed. But we're even getting more relaxed in our semantic analysis, because here really like almost everything is allowed in JavaScript. It may lead to errors, right? But you will seldom hit really a hard limit in JavaScript. There are a lot of things allowed, where C# tries to be really, really strict, even though many times it actually wouldn't need to be. Right, so let's talk about the abstract syntax tree. I just remarked that it's a tree, but it's actually the most important tree, and it usually consists in many languages of two things: statements and expressions. There are languages that don't have statements, and that's cool. It's really powerful to not have any statements. That liberates you, and that gives you a lot of freedom for many things. So a statement usually doesn't return anything, right? So expression you can always, let's say, combine together as you want to. Statements you can't do. You can't combine a while statement and a for statement into a single thing. You can have two after each other or nested within, whatever, right? But they can't be combined. You can't say, this is my while, then you make a plus, and then this is your for. That doesn't make any sense, because your while doesn't compute to anything. It does do something. And as said, there are languages which can live without expressions. Then there are certain semantics there to be respected. But yeah, let's say in our language, we build it more traditionally, and we have statements in there too. Quite often, statements are triggered via convention. So for instance, a keyword, we know for, while, I mean, I don't know, for a function statement, we may use a function or whatever. So there are all these things that are possible. Whereas expressions consist of operands and operators, and expressions always give you back a new value, right? So even though that value could be, depending on the kind of expression, like let's say void, it gives you back something, and you could do something with it. And you could then combine it, right? So if you have a 2 + 3, I mean, no one would question that you can combine it with another +5 or so, right? You can always go bigger and bigger and nest that and whatever. So these are expressions. They have a value always, and they can be combined in other expressions. Right. So if we form a simple tree, here is one. This is our, let's say, code that we pass. We have a = 1 + 2 × 3. Great. So we have a on the left-hand side. Then this whole is an assignment expression. And then we say, okay, we got a plus expression, we got a multiplication expression. And the only question then is, in terms of precedence, which one is run first. So here we see we're going from the right-hand side. We first execute the multiplication, and then we bubble up. And by the way, if you look at that, well, this is already a nice interpretation pattern, and you can use a tree to make interpretations. But as we will see later, you shouldn't for performance reasons. So that should be linear again. So we started linearly, right? We started with a one-dimensional stream of bytes that was coming in, to a one-dimensional stream of characters, a one-dimensional stream of tokens. And then we suddenly had a tree structure with all these expressions and statements. And at the end of the day, after the analysis and so on, when we spit out code, and it doesn't matter if it should be, let's say, interpreted or directly compiled, it should be linear again. And there are reasons for that. Okay, great. More complicated example, but same thing. And there you see we're not always evaluating from the right-hand side, because the 4 + 5 is not executed at all. The multiplication is stronger, and so this one drags a new tree on the left-hand side. And so we start here from the left with a multiplication 1 × 2, then we multiply the result with 4, add it to 5, add it to 3, and we are done. And again, this is a thing that we should be able to replicate in our language. You may, of course, come up with a language that has different rules, also different rules than you normally apply to mathematics, and you can change the precedence here. But independent of that, I mean, you want to have, let's say, an operator, a hierarchy where you say, okay, this operator is more important than the other. So it will always, if there is this let's say ambiguity, it will always run beforehand. Cool. So this is the moment where we look a little bit into Majors itself. Majors has a nice way of reflecting itself. So it has, for instance, what we see here in this example, but we will look in there in a second. We see it has an AST command. This is just a function. You can give it a string, which is code, and then it will show you, and this is actually Majors code, and then it will show you actually what it would see if this code would be, let's say, transformed to an abstract syntax tree. And it will give you this representation, but we will do that in a second in the console anyway. So finally, let's say we created this whole thing. We created an abstract syntax tree. How can we efficiently, let's say, analyze it? And then, of course, from this syntax tree, make something like, for instance, an output that could be regarded as an intermediate language, right? So how do we do that? And the way how to do it is usually with a so-called a visitor pattern. It's one of the classic software design patterns. And in there, you usually define two things. You define a so-called tree walker. That's a class where you want to consume your tree. So you can have different tree walkers for different things. So for instance, you could have a tree walker to analyze your code. You can have a tree walker to create the output of your code. And at the end of the day, each of these parts of our abstract syntax tree implements the walkable. So it can be part of a visitor. The walkable just has an accept function, and it accepts this visitor. And then the mechanism is quite simple, right? So each node in our tree accepts the visitor, and each node itself knows then what to do next. So it knows, for instance, by the way, I'm a var statement, so I call visit from myself in the walker, and therefore the right method is called in the walker. And that way you visit all the nodes and you always have it strongly typed, which is quite nice, because otherwise you have this problem of not knowing what kind of type you have. You just know, it may be an I expression or an I statement, but I don't know what to do with it. And you would need to check for all the possibilities here. You would need to check, is it a var statement? Is it a block statement? Is it a binary expression? And that alone is quite cumbersome, but it also has the problem that if you introduce a new expression, then your code just breaks, right? I mean, you now handle one case is not handled. And that way it will always be handled because the tree walker extends. And this tree walker you can find in all compilers out there. It's always there. It's a powerful pattern that, especially for such trees, is really helpful. And if you write, for instance, using Roslyn, a custom analyzer, then you implicitly use a walker too, even though there are some levels of abstraction and you don't need to implement all the visits here. Right. So PowerShell time, majors, and this is a simple Rappl read eval print loop, which means I can just type in things and I actually see the outcome here. So 2 + 3 is 5. That's awesome. And I could also define a function. Let's say it's a function f, and this is just x + y times z. And if I run that, I think this result may be correct because 3 × 4 is 12, + 2 is 14. So that's awesome. And you see that way already some things of that language. For instance, you could define a new function g just by handing over one argument to f. And now this behaves the same as if I would have typed f2, 3, 4. So that uses patterns like currying out of the box, which is quite nice. But of course, you can go ahead and say, okay, now give me the abstract syntax tree of what we've seen beforehand. And it will actually resolve all that for you. So it will now say, okay, at my root here, I have a binary plus, and then inside here, I have a left value, a right value. So the right is a constant, is 5. The left value, I mean, that's another plus statement. And then at the end, and that's the first things that will be evaluated, are these multiplications. And of course, you can get a little bit more complicated. So what happens if we, for instance, have a function with an empty body? So you see that's an assignment expression now. And we introduce a new variable called f. And there's a value, and that's just this function. And it has just a block body. You can make some investigations here. This is a really simple Rappl. I mean, the most sophisticated thing that it has is that it has completion. So for instance, I don't know, I can just tap here and see, oh, okay, there's a concat, there's a console, and even console has something like a write line. So let's just write out 2 + 3, and that's it. So that doesn't give anything back. That's just undefined. But I mean, I just output here the 2 + 3, and I can say this is my output. Something like this, right? Nice. Okay, so that is what essentially this toy language there does, what it can do. Let's go back and have a view on a little bit of the internals. So I just mentioned beforehand that an operator hierarchy is quite important, right? And this is usually not so trivial to implement. How are you doing that? But there's a simple trick, and that's illustrated now in the sequence diagram here. And the trick is called the so-called broad parsing. So what you're doing is that you wrap your different, let's say, operators all in different functions in your compiler. So you may have a function that handles assignment operators. You may have a function that handles plus operations, multiplication operations, or atomics, like, I don't know, a number literal. And if you make them in order of the precedence, starting with the weakest, and then calling recursively the stronger ones inside, you will always succeed. So what's happening is you start with assignment, that's your root, because you know that's the weakest of all of them. And then you say, oh, let's first check, are we in a plus situation? So you call the in this case, additive function. Then this one says, oh, are we in a multiplication situation? So you call multiplication. And then this one says, well, do we have, I'm the strongest one, so apparently no. But let's see if we do have an atomic here. So something like a number literal. And here, for instance, in this example, it says, yes, there's a 3. So it returns the 3. Multiplication may say, oh, there's no multiplication sign. Let's hand it back. But then there's maybe a plus. So this one stays in the plus case, etc. And then it goes down again. And if you do that, you have, of course, implicitly by using this pattern, quite some recursive calls, but you use this stack then of your recursive calls to actually keep track of in what situation you are. And quite naturally, you get out a tree that, is shown here. I hope you can read that. That has the expressions 3 + 1 × 2 × 4 + 5. And it just naturally comes out if you have this structure. There's no need of any book tracking, etc., because again, the call stack does the book keeping for you. And this simple trick of a broad parsing actually enables you to very easily have the precedence climbing implemented in your code. So quite a neat trick. Right, virtual machines. I mentioned them beforehand. What's a VM anyway? So apparently there are multiple kinds of VMs. There are system virtual machines, there are process virtual machines. And usually, we're not about system virtual machines. So system virtual machine really tries to emulate kind of a system. So that's what you're using when you're using, I don't know, an Ubuntu image running in Windows. Usually all the real computer system is then emulated behind, and the Ubuntu just sits on top of that and believes it's running on a real system. But in comparison, if you have a process virtual machine, then what you want to do is that you design a language for a toy computer, essentially, right? And this is what, for instance, MSIL is. So it's not a language that can be read by any computer, even though there have been efforts in the past. But instead, it's a language that can be read by another application, which is this in-process running virtual machine, right? It's the core language runtime. And we can have a look at the intermediate language of majors. There's a command like AST, it's called IL, and it will give us the, let's say, representation in form of strings of the internals here. And it can even do more complicated things, as we will see in the demo. So we are still here, and yeah, maybe let's just use our function that we had beforehand, and let's just see what it makes if we say intermediate language. So it just tells us that it starts a new function, it puts some args in there, and then that's it. If we now put in some args, we see it populates these args, right? So it has 3 arguments and it labels them X, Y, Z, and that's it. There is no code inside the body, so it knows about this. So we could write some code in here, and yeah, it could contain this code. So in this case, we see, oh, it places some constants there. It already knows about that. It then makes a call operation, and then gets the value of the let's say value stack, right? And yeah, I mean, this is all there is. This is completely arbitrary designed, like, for instance, of course, MSIL is or was in the beginning. Now, of course, that's well specified, but that is really just an arbitrary representation. What it helps us to think about, though, is we see this and we compare it with the abstract syntax tree, and we see that it is now linear, whereas the tree really has this tree-like structure. Some things are more nested in depth than others. All right, so also looking at the time, I would like to go a little bit in the code, but I think I've run out of time. You will find the code of majors on GitHub. Maybe there's one or the other question would be great. Otherwise, I will post everything also on my Twitter account, so have a look there, and you will also find the presentation online. Happy to take any questions now, and I think we even have time for a little bit more. So if you guys want to know a little bit more or something was unclear, just ask. Always happy to answer.
Exactly. Thank you, Florian. And I also ask the audience to just write the question in the Q&A tool if you have any questions. So we already have a couple of them. So Gaetano, he was the first one to post the question. He's asking, our client request was to inject some C# code from outside of an application. Could this be a real scenario? What can be a real scenario otherwise?
Okay, so if I understand the question correctly, there is some way in an application that you can bring in arbitrary C# code, so someone may give it to you, right? And then you need to do something with it. I don't know, run it. That's how I understand the question. There are scenarios like this. That's, of course, one of the reasons why Majors was developed in the first place. Another thing that you can do with majors is exactly to replace things like that. Now, if you run C# in your application, you can do that. You can actually either come up with your own, let's say, interpreter or compiler within your application, or you use Roslyn. But in all these cases, the problem is, what kind of API do you now offer? What can they use? Because, for instance, if they could use something like process, or could hook on to, let's say, system internals, then you may have opened, let's say, your application for kind of unrestricted access, which is always bad from a security perspective. So here, a kind of sandboxed environment makes more sense. This is where languages like Majors, but there are others, come in very handy, because they allow you to control everything that can go in there with all the APIs that you offer there. And that allows you really to have something that is not only fast, really quickly interpreted, really lightweight, but also secure. And so I would always advocate to use that more instead of just allowing C# to be inserted from arbitrary locations.
Okay, thank you. The next question is, what tool do you use to see generated IL code from a C# code?
So here the tool I used was or is called LinkPad. So Link, LINQ, like the language integrated query. It's an old tool. It's a quite popular tool from also an author of the C# reference book. And primarily it was, let's say, created for inspecting link queries. So it also has these database connections and so on. But it's really helpful to just try out simple things, or inspect intermediate language code, or have a look at the generated tree. So it's quite cool for these purposes.
Okay, and the last question from Tommaso: where can I find more information on the shown precedence climbing pattern?
Yeah, I think it is. It's not something I came up with, of course. It's a quite popular technique. If you look up PRAT, that's written P-R-A-T-T, PRAT parsing or PRAT precedence climber in Google, I think you should find out more results. I will look up if I find some good reference there. I will post it on my Twitter account after the talk, if I find a good reference. But I think there should be plenty. I mean, as said, it will also, I think, discussed in depth in the Dragon book. That's a very popular compiler book. So it's called Dragon book because it has a dragon, I think, on the cover. It's an old book, but I mean, yeah, it's like wine, right? So it's old, but it only gets better over time. It's not outdated knowledge there. It's all very, very much the same. Compilers didn't change in the last 20 years. They got just more complicated, but it didn't change.
Okay, that's good to know. Florian, thank you very much for your presentation. I hope to see you soon again, also maybe also in person at a real event, physical event. So thank you again, stay healthy, and goodbye.
You too, bye, have a great day, everyone.
Okay, so we are moving on with the next talk. Before that, we will have a short break of 13 minutes. So at 3 p.m. sharp, we will start with Adam. Adam will have a talk called Hacking C# from the Inside, how to do anything in .NET. Pretty much looking forward to that one. So take the time, get a new coffee or whatever you like, and see you in a couple of minutes again. Hey everyone, I made a mistake. The next talk is not at 3 p.m., it's at 4 p.m. as the slide says. So you have even a bit more time, maybe for a late lunch. So see you in 1 hour again.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now. Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now. Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Okay, hello everyone, welcome back to the WeAreDevelopers.net day. I am here with Adam from Amazon. Thanks for joining us, Adam. How are you today?
Doing good, again, glad to be here. Thank you for inviting me.
Perfect. Where are you joining us from actually?
I am actually staying in Poland at this moment, in Krakow, beautiful town at the south of the country.
Okay, that's nice. And how is the weather?
It's very good. It's lovely, actually.
Okay, hello everyone, welcome back to the WeAreDevelopers. Tell me, I am here with Adam from Tell me what will we learn from you today? Thanks for joining us.
That's actually a very good question. My talk will be about some building blocks, how to hack multiple things in .NET platform. So while it may not necessarily I'm actually staying in Poland at this moment, day one, it's definitely very interesting and will encourage a lot of people to dive deep into the platform and internals. It's very good. It's lovely, actually.
Okay, hello everyone, welcome back to the WeAreDevelopers. Tell me,
thank you. Oh, hello everyone. My name is Adam again. It's very good. It's lovely. Hacking C#. So what we are going to do today is we are going to see that even though the C# as a language is a very high level one and it's supposed to be safe, supposed to be type safe and garbage collected, we'll actually learn how to break up things in this language and how to, let's say, abuse type system and other things around that. Why? Because we just want to do it for fun and profit. We would like to see that it's possible, see that C# and .NET as a platform, even though it's supposed to be safe and high level, it gives us this ability to control everything under the hood. So this is what we are going to learn. Before we actually move on, a couple words about me. I'm a software engineer with like almost 10 years of experience with backend, frontend, full stack, everything like this. Currently staying at Amazon doing some machine learning stuff with like video recommendations or voice generation. I'm also a blogger. Feel free to take a look at blog.adamfurmanek.pl, and I highly encourage you to take a look at my book called .NET Internals Cookbook, where I cover plenty of these things about .NET C# internals. Drop me a line on email, Twitter, if you'd like to reach out. Feel free to do it the way you prefer. Also, when it comes to asking questions during this talk, feel free to do it as we go, and I'll try to answer them alive, so to answer all the questions you may have about the things we are going to cover. So the agenda for this talk, as I mentioned, we are going to hack the platform, and the goal is to provide you with a couple of building blocks. I won't be showing you anything like end-to-end solution. What I'll be showing you is plenty of various things, how to change asynchronous programming, how to take care of memory management, how to actually abuse the type system, etc., etc. We have plenty of different examples, so we'll just do as many of them as we can, as the time allows us. And what we have in agenda is we'll start with something simple, very high level, like we will try to avoid the dynamic dispatch, the polymorphism of the .NET platform. And then we'll do yet another thing, which is not super low level hacky, which is awaiting async void methods in C# language. Then we'll actually enter the world of some unsafe memory, unsafe operations. We'll try to run like a machine code stored in an array. Then we'll do some plenty useful things like running apps on different desktops, handling Stack Overflow exception, etc. And if times allows us, we will try to abuse the type system. Okay, so let's begin. So the first thing is we would like to avoid the dynamic dispatch. So the dynamic dispatch in .NET and generally in object-oriented programming is that we do have multiple classes which derive from each other. So we have a base class called base here, and then we have this inheritance hierarchy with derived and derived two classes. So what we do have as well is the virtual method called foo. And because it's overridden in both of these subclasses, what we typically expect is when we create an instance of any of these three classes, the concrete specific foo implementation is being executed. So imagine that we do this line on the very right of the screen, which is base b equals to new derived 2. What we do is when we call b.foo with parameter 1, 2, 3, the actual expectation is, hey, this one method should be called because b is of type derived 2, so the foo method from derived 2 should be executed. But the question comes, hey, can we actually call method foo from like
like derived class or from the base class. So can we stop the dynamic dispatch and statically control which foo implementation we would like to run? And the answer is yes, we can do that. And this is what we are trying to do now in this code snippet. So I'm going to show you how it works with the actual code. So we start with these three classes which are shown you on the slides, right? So we do have base class with foo, which is virtual, and then we have derived and derived2 with foo, which do override the base class, the base method. So what we do initially is we would like to use the intermediate language instructions and differentiate between the virtual dispatch and the static dispatch. So on the intermediate language level, there are actually two instructions. First of them is called the call instruction, which is used to call the method by the method descriptor. So we need to, in the intermediate language, which is like a bytecode for .NET, which is the high-level language just below the C# language. When you compile C#, you're actually getting the intermediate language output. So the intermediate language, the IO for short, we do have this instruction, which is called call, where we define or where we need to specify the method we would like to execute. On the other hand, there is another instruction called call virt, which is used to call methods which are late bound on the object, so which are dynamically dispatched based on the runtime type. So what happens under the hood when we in the code, what we try to do is when we do execute the regular b.foo, the call virt instruction is emitted. But what we'd like to do is we would like to emit another instruction, which is call, to actually avoid the dynamic dispatch altogether and do the static invocation. So what we do is, because we would like to have this compiler support and type safety, etc., what we want to do is we would like to use, for instance, a lambda expression, which we will then examine to figure out which method we would like to do, which we would like to call. So normally this bfoo would call the derived method with the dynamic dispatch. But what we want to do is we pass this method. We would like to extract this foo method and then extract this type derived and then call the foo method from the type named derived. So what we do in the invoke method is first we check, hey, is this lambda, which we pass here as an expression of action, not the action itself. So it's not a delegate, it's like a static syntax tree of the code we would like to execute. So this lambda is not executed here at all, it's only specifying what we would like to do. So we take this lambda, we check whether it's actually a method call. If it's not, then we throw. This is actually a bad part of this code because we do not have like full compile time safety, but once we cross this or once we ignore this thingy, we are safe again. So we do have this expression call, we get the body, we get all the arguments, and finally we get the method which we would like to call. So in this case, this method will be the foo method. So what we need to do is when we get this method, we want to get this method to call from the caller of type T. Okay, so this type T in this line comes from the generic parameter. So we would like to call the method which has exactly the same name and exactly the same parameters, but comes from the type named derived. So what we do is we generate a piece of intermediate language code. So we create a dynamic method, yada, yada. We create the IO generator. And what we do next is we need to load all the parameters. So we load the parameters one by one. And also we evaluate these parameters if needed. This is actually important because here in this lambda, what we have here is we have the expression of calculation 123 plus 456, right? We do not want to pass this as another expression. We want to evaluate this and calculate the sum of these two numbers. So we get these parameters, we push them on the stack, and finally the most important line comes here. You can see we are using the call instruction, not necessarily the call virt instruction. And because this is the call instruction, what we can see here is we are executing the code which comes from the class derived, even though the type of the instance we passed was derived too. So yes, we've beaten the dynamic dispatch and we called this method statically. So this is the first hack we can do. And just to show you that, hey, things like this are possible, right? We can, if we got a little down below the C# level, we can actually start doing some fancy stuff. But let's now stick to the high level for a little longer, and let's try awaiting async void methods. So the issue with async void methods is we cannot await them directly because, hey, they are void. They do not return anything for us, which would be awaitable. They do not return task. They do not return value task. They return simply nothing because, hey, they are void. So now the question comes, how can we await async void methods? And the answer to that question is we need to re-implement a bit of .NET Platform, which is behind the scenes. So what we need to actually do is we need to implement our custom task scheduler and our custom synchronization context. So what we start with is let's first see what we are trying to call. So this is the async void method we would like to execute. And you can see that this method waits for 1 second and then throws the exception. In a regular application flow, this would basically kill our application, right? Because the exception would be propagated out of bounds in the out of bound manner. It would kill the application probably with some nasty exception printed out to the user. This is definitely not what we would like to do. We would like to not only await this method, but also handle this exception, catch it, and execute normally. So what we need to do is we start with creating our custom scheduler. And in this custom scheduler, we just create a collection of tasks. So this scheduler, we just aggregate all these tasks we would like to schedule using it, and then we'll execute them one by one. So this is the task scheduler. And the other important part of the asynchronous programming is called the synchronization context. And here I highly encourage you to take a look at my other talk, which is called Internals of Async, where I explain all those bits and pieces. Here I just show you how to do it like in a very shortened scenario. So we create a custom synchronization context where we use our custom task scheduler, and we also create an instance of task factory, okay? And in this task factory, we hide the .NET task scheduler and we provide our custom one. So what is going to happen next is whenever we start running things through this synchronization context, all the tasks will be scheduled and created by our scheduler and by our task factory. So the important thing is we do have two methods called operation started and operation completed. So we can just wait for them and count them, right? So we know where all these things still have all these things like tied together. And the ultimate answer, or the ultimate trick how to await async void methods is we need to replace the synchronization context. We need to use our custom one, and then we just create all these tasks and execute them one by one by one, okay? Ultimately, at the very end, we just restore the original synchronization context, but the important part is here. We execute this code in the task.run part. So what we need to do now is instead of calling throw method like directly, we can just call it using our static helper method myContext.run. And what we get in return is the task object, which we can simply await using getAwaiter.getResult or using .result or using .wait or simply by calling await, because this is the task like every other task in the application. Ultimately, we can also catch the exception. So you can see in the output, we not only we did not crash the application, but also like we printed out the exception. So we presented everything correctly. So this is the way how you can actually await async void methods. And before moving on to the actually next demo, there is a question on the chat. Does VB.NET still have any relevance nowadays? That's a very tricky question, actually. I have been programming in VB.NET like 5 years back. I don't know if there are any new applications in VB.NET, but I do believe there is a plenty of other apps which still need to be supported and extended. So I would say it depends, probably depends on the market, but definitely VB.NET is still alive and probably will be with us for a couple more years. Moving on. So we now have seen two fancy high-level examples how to actually do something by re-implementing part of either intermediate language or part of the like .NET internal classes to run the synchronization context, etc. Now we actually would like to go a little deeper, a little low levelish. So we would like to run machine code from a byte array. When I'm saying machine code here, I mean the actual raw bytes representing some native code or native execution, which we have at the very bottom executed directly on the CPU, right? So I'm not even talking about the assembly language, because the assembly language is still a pretty high level in these terms because we use mnemonics over there. So one move instruction or one add instruction instruction can be actually compiled to different machine instructions depending on the parameters we pass. We would like to be a little the one level below, and we would like to actually implement the code directly using the raw bytes representing the instructions to execute. So now, before we do that, we need to learn something about functions in .NET. So typically a function in .NET is JIT compiled, meaning that we do have this intermediate language, which is not a native code representing the function, but it's an intermediate language which is then compiled in runtime by the just-in-time compiler. The method can be also pre-generated using Engine or ready to run depending on which platform we are, but ultimately the method must get the machine code. There can be multiple machine codes or multiple like function implementations for given intermediate language, because now in .NET Core we have multi-tiered compilation, right? But what we need to remember at the very end of the day, there must be a machine code which is executed. And each method has also a specific calling convention, meaning that when we are on the CPU level, we need to remember how to pass registers, we need to remember how to pass parameters via stack or whatever else, who cleans up the stack, etc., etc. So this is all of that is taken care by the just-in-time compiler, by the platform. However, once we start calling these methods like manually by hand, we need to know how these things work all together so we can re-implement them in the machine code. And one more important thing is each function is .NET has the so-called method descriptor. It's a piece of metadata explaining where this method comes from, which class holds it, where the intermediate language is for that method, where the machine code for that method is, how long it is, yada, yada. There are plenty of different things tied or associated with this method, and we can actually use these method descriptors in runtime using reflection to get some knowledge about these functions. And we'll see how to actually use these method descriptors to get the machine code and a couple other things to re-implement the functions we would like to do. So when it comes to machine code, it's not an assembly code, as I already mentioned. One assembly mnemonic can be compiled down to different machine code instructions. So when we are dealing with machine code, we need to remember all these differences. It's actually important also to keep in mind these technical differences or technical details about how the machine code is generated, that it cannot be read backwards easily, that there is an endianness, that we need to remember the instruction length, etc., etc. But at the very end, because we are running on x86 architecture, at least the demos I'm showing you today are running on x86, this code is basically a bunch of bytes. We can just store this as a data, like as, let's say, an ASCII string, and then we can change the memory page protection to be able to execute this code directly. And this is what we are going to do. Now, the question is, how do we get the machine code? And the answer is we probably do not want to write it like by hand, because the machine code which we need to get is ultimately like this set or this list of bytes, right? Because this is a machine code. What we would like to do instead is we would like to start with this assembly code, which is like move EAX123, and then compile or assemble this down to the machine code. And I highly encourage you to take a look at this link. For instance, this is like an online x86 assembler. So you just put some machine code in there, and you can get directly like the all byte arrays, which you can just copy into your C# source code and start using. So this is the idea what we are trying to do. We'll implement a super simple function in an assembly language, assemble it down to the machine code, and then execute this machine code from C# directly. So in order to do that, there are actually two ways I'm going to show you. First of them is based on the .NET API. There is a method marshal.getDelegate for function pointer, which is used to actually exchange pointers to functions between C# and some unmanaged code, like C++ CLI or C++ or Delphi or whatever else, right? There is a pointer under the hood, which is managed, the calling convention is managed, etc., etc. And this method takes care of all of that. On the other hand, the other solution we can use is we can take existing machine code, like existing .NET method, modify it in place on a machine code level, and just interject some jump instruction to do whatever we want to do. And that's the thingy. And the important thing about jumps is that on the x86 architecture, they are relative, meaning that when we say jump 123, we are actually not jumping to the absolute address 123, but we jump 123 bytes forward in the instruction pointer. To do an absolute jump, we will typically use the trick, which is push plus return. So we will push the address onto the execution stack, and then we'll return so the address is taken down, and then the absolute jump is executed by the CPU. So this is what we are going to do. And let's now see this code, how it works in action, okay? So we start with this Marshall approach. So we will be using .NET API. So let me just select to set a startup project, okay, and run the application. And what we are trying to do now is we start with two delegates. So one of them is the action delegate, which accepts one integer parameter. The other delegate is basically function of integer, so one integer parameter and one integer returned as the output, okay? This is just to show you that we can implement basically any function and have compiler type safety, etc., etc. So what we start with is, let's consider this func example. So we would like to implement a simple addition method. So we would like to implement a method which gets an integer parameter and increases it by 4. So adds 4 to the parameter we get, and then returns the result. So what we have here is, here we store basically the assembly code doing the magic. So because we know the parameter is passed through the stack, and this is actually the calling convention I've been mentioning a couple times. So we need to know how these parameters are delivered to the function. And this parameter we need to use is actually delivered via the stack. So we get it, we put it in the EAX register, we then add number 4 to it, so we increase it by 4, and ultimately we just return. And you can see these raw bytes are actually the machine instructions doing the operations I'm showing you here. So what we would like to do is we would like to get this delegate, and notice that this is a regular .NET delegate. So we do have a compile time safety here, how to validate parameters, etc. So we just call it function 23, and this should execute this calculation 23 plus 4 equals to 27. This is what we expect to get from here. So how do we generate this thing? We use this func generator, and this func generator, what it does is, sorry, where it is? It is here. So we do have a method generate, which accepts this generic parameter of the delegate we would like to create. The first thing we need to do is we need to get the address of the machine code of the actual method we are trying to execute. So we need to get this array of bytes. We would like to pin it so it's not moved by the garbage collector. It's not moved to the other place in the memory. And then because we know the internal structure of the byte array, that it is that the first 4 bytes of the array are occupied for the method handle, and then the 4 bytes are occupied for the size of the array, then we know that the actual content in this array is 8 bytes from the beginning. So we just pin this thingy to get the address, and we increment it by 8, so we know where the machine code starts, okay? The next thing we need to do is, because we are running on the x86 architecture, and this array, this byte of data array, is stored in a memory page, which is not allowed to be executed. So there is a memory protection, so we cannot execute this memory page. What we need to do is we need to ask the Windows operating system, hey, please unlock this page for me, so I can actually start executing it. And to do that, when we call unlock page, we are actually using the WinAPI method with virtual protect, which unlocks the method. If you would like to do that on, let's say, some Unix system, you would do exactly the same, only call mprotect method, but the rest of the concept is the same. So you can actually migrate or port this application to Linux and any other operating system, as long as you can control the memory protection, which is not allowed on all the architectures. The ultimate thing we are doing is we call this Marshall method, get delegate for function pointer, and we get this address, we specify what pointer we would like to get, what delegate, we just cast it, and that is all. So this is what we do. And the other test we would like to do is we would like to jump from our method to actually show you a little bit more of a trickery. So we would like to call this method the action test, in which we generate, again using machine code, we would like to jump to somewhere else, to some other method. So this delegate we would like to use to actually call this method, myWriteLine, and pass this text, this integer, to print it out. So what we do here is we actually execute the instruction that, hey, we are pushing the absolute address of the method we would like to execute. And this absolute address is actually the method address, which we get from the method descriptor of the method myWriteLine. So this is the metadata I mentioned to you. We can actually get, using reflection, we can get the method handle to the myWriteLine method. Then we can actually compile this method if needed. So it's JIT compiled, we have the machine code. And ultimately, we can get a direct pointer to the machine code backing this single method. So we do that, and ultimately, we generate a piece of machine code which pushes this address on the stack and then returns. So we do this absolute jump trick. Now, when we run this application, what is happening here is you can actually see that we did print out things from here. So we are in the myWriteLine. You can even see the addresses like hexadecimal machine code addresses and the value 5. And also, when we scroll down to the other example we wanted to execute, we remember that we wanted to start with number 23 and add 4 to it. And you can see there is 27 printed out. So it's 23 plus 4. So this is what we can do with Marshall get delegate for function, but it's not the end of the story. If we wanted to do it the hard way, we can actually do it without any .NET support at all, just by jumping between methods, the similar thing we have already did. So what we do now is, apart from the code we have seen, we need to create we start with a base stub class. And the base stub class is basically a class which holds one integer, one pointer to the method which we would like to actually execute. Then we derive from this base stub with some action and some func, so two classes representing actual delegates, and we just create a stub method on these types. So we do have a piece of a machine code which is generated for us by .NET. Okay, then the idea is we will replace this code in runtime with machine instructions performing the jump. So we will create, we will compile these things with C# compiler, then just-in-time compiler will compile them to generate machine code, and then we'll replace this code with jump instruction to the address specified by the field stored in the base address. So what we are now trying to do is we actually do exactly the same code as before, only the generate method from the generator is different this time. And what we do now is, once again, we get the address of the method, we unlock it. Now we store the address of the actual code which we'd like to execute in the stub class. And then what we do is we emit this little instruction here, which is basically doing the magic. Hey, push this address from this field called target, push it to the stack, and then return to perform the absolute jump. And what we are doing here, the func instruction is completely not interesting this time because it works the same, but notice what is interesting here. In this myWriteLine method, I am actually calling getType. So I want to see, hey, who am I? What class am I actually when I'm executing this method? And you can see that when this method is executed, we would expect this to be printed out, hey, it's class program. But it's not class program, it's action int class. And the answer, why is that? The answer is because we took this original method, and while executing this line of code, we did a physical CPU jump to this single line. So even though we did jump, .NET doesn't know that we switched methods in the background. So it just holds the original this pointer, and it thinks we are still in the action int class, even though we are executing something completely different. So this is how we can execute virtually any instructions using C#, using .NET. No, and actually we do not even need the .NET support to do so. How can we use that for, or what can we do else with these things? We can actually start hijacking methods. So we can, for instance, override sealed methods to do some magic. And what we are going to do is we are actually, we'll try to hack these methods so other methods are called than expected. So the first thing we do is, let's start with this test class, and then we do have method static string method called return string, which returns some string, right? Original string. And then we would like to have another method called return string hijacked, which returns some different string. Now, what we would like to do is we would like to convince .NET that when someone calls this return string method, actually the return string hijacked should be executed. And there are again two ways to do it. And how are we going to do that is we are going to hijack the method return string with return string hijacked. Now, how do we do that? So the hijack method in this example, one idea is to basically restore or override the metadata which is behind the scenes, behind the in the method descriptor. So we do have the original method like return string, and we do have the target method called return string hijacked. And what we do is we first JIT compile them, then we get the address of the original method, then we get the address of the target method. And what we do is we know that the function pointer in typical case, so the pointer pointing to the machine code which is for given method, is stored 8 bytes from the beginning of the method descriptor. So what we do is we just change this address. We go and replace this pointer with the target address, okay? And when we do this, what happens next is we do this thingy. So we hijack this method, and notice then we call test class dot return string, okay? Actually, we call this method twice, here before the hijacking and here after the hijacking. And you can see that in the first case, before the hijacking, we executed the original string, but after the hijacking, the modified string was returned because we hijacked this method, so some different method is being executed. And this is one approach to do so. So step in and replace the metadata which is backing the actual method. But there is yet another method, yet another trick we can use. And this is based on the same idea we had when we were generating the code, right? We can jump between methods. So we have exactly the same code as before when it comes to the return string, when it comes to the return string hijacked, when it comes to calling this method and hijacking these methods, okay? What we need to do now is instead of changing the metadata, we get the method handle, the actual machine code address of the source method, actual machine code address of the target method. We unlock both of these methods. And what we do next is we modify the original method with the instructions, with the jump instruction pointing to the target method. And here, instead of doing this absolute jump trick, we can actually do the regular jump instruction. So this is the regular jump instruction, and here we specify the offset, yada, yada. That is all basically the same concept, only different way of doing that. So you can see again that even though we executed the method twice, you can see there is original string and there is modified string being executed. So when we call this method twice, before and after hijacking, we get a different result. Okay, so this is what we do when it comes to method hijacking. Now comes the question, hey, is it useful at all? Why would we ever do tricks like this? Why would we ever start hacking all these things all together? And the answer is, well, there are a couple of situations when these hacks are actually useful and these hacks can help you a lot. So I'm going to show you an actual example which I'm using and I've been using in production for some time, which is the desktop API extender. So notice, you probably do not see it yet, but you should see it now. Notice here in the very bottom right corner of my virtual machine, there is this icon. This is the application called desktops, and it comes from sysinternals package. So it allows you to create a physical separated desktops in your operating system. So you can basically switch desktops like this. Okay, so this is nothing special. This application have been in in Windows for like last 20 years. It's always been there. The API was always there. So now comes the question. I would like to run a Notepad.exe application, but I would like to run it on different desktop. Now comes the question, how do I do that? And if you take a look at the WinAPI, like the WinAPI method for running the application, starting the process, there is a nice field which allows you to specify on which desktop you would like to run this application. However, when we start dwelling into or digging into the .NET Create Process API, which covers or which wraps the WinAPI method, you can see that under the hood, and this is actual part of .NET source code, under the hood, the startup infrastructure is being used to hold this variable specifying the desktop which we would like to use. And unfortunately, this LP desktop parameter is always set to 0. So .NET does not allow you, does not let you to specify on which desktop you would like to execute this application. So now comes the question, okay, what can we do about that? Well, there are multiple solutions. First solution would be just copy the create process code from the C# GitHub or whatever else, expose this variable and have it running this way. Well, this works. The issue with this approach or the drawback is that you basically fork a piece of .NET platform, and if they change it here, then obviously you need to change it as well. So you need to keep it in syncs to be consistent and to be safe. So it's probably not the best idea. The other idea could be, okay, maybe let's just use the create process method from WinAPI directly, just by using pinvoke or just by calling it from C++ CLI or whatever else. Well, this works. The drawback is that, hey, we do expose this thingy and we lose all the .NET objects which we have around. So we lose all the benefits of create process being actually a managed code provided by .NET. So what can we do? Well, the first solution is let's hack .NET Platform to get access to this structure. But now the question is, how do we do that? Well, because it's a structure, because it's a class which is created here and it's not called using any factory, then we cannot like override this thingy, inherit, use polymorphism, etc. This class, instance of this class is created right here, and the process then is just executed. But what we can do is we can hijack the constructor of this class. So this is what we are going to do now. So in this desktop API extender thingy, what we would like to do is we would like to hijack the desktop logic. So we find the class called startup info, we get its constructor, and ultimately we hijack this constructor so the other constructor is being executed. What do we do in the other constructor? Well, again, we need to take a look what's is being executed in the regular constructor. So the regular thingy basically sets the CB, so the size of this structure, so it can be used for interrupting with WinAPI. So what we do is, well, we do exactly the same, using reflection, getting the private field, yada yada, setting value. But the other thing we can do is we check whether we specify that we would like to run this on some different desktop. And in that case, we get this LP desktop variable and we just change its value. Okay, so see what's going to happen now. I'm going to run notepad.exe without specifying the desktop, so it should be executed on the default desktop. So let me run this application. You can see that it's being built and should execute in a sec, and the the notepad.exe should appear in a sec. Come on, my virtual machine is really slow this time. Sorry, I ran it with debug mode. That explains everything. Instead of Control F5. Okay, yeah. So you can see there is this. Okay, let's stop it in this way. I'm not going to run it with debug mode. Let's run it this time again without debugging. And what we should see now is the notepad.exe pops up here, right on the desktop I'm on. Okay, what we do next is we are waiting with this console read line. Okay, and what I would like to do is when I press enter here, the read line is being executed, the application finishes. You can see no notepad.exe at all, but notice what is happening. I'm running this notepad.exe on the other desktop. So if I switch now to the other desktop, the notepad.exe is there. So this is how we can execute the notepad.exe somewhere else on actually any application somewhere else. So that's one example of doing some machinery with this method overrides. The other trick we are going to do is we are going to handle unhandled exceptions which are thrown on a thread. So if you do know .NET, then you probably know that an unhandled exception on a thread kills the whole application. Whenever you create a thread, always catch the exception. Otherwise, your thread is going to die. And with that thread dying, your whole application will be taken down. So what we are trying to do is we are creating a thread, and we specify that the code for this thread is yada yada. We just laugh and we throw exception, which kills the application. And then we start this thingy. Okay. We would like to now introduce a try-catch block inside this lambda without actually modifying the lambda here. What can we do? Again, we can hijack the thread constructor to do the magic. So what we do is we actually modify handler. So instead of executing the regular thread start, we execute a different lambda to wrap this thread start with the try-catch logic. How do we do that? Well, again, the same magic, even though the code is a little longer this time. We get the thread constructor, and then we just hijack it with some different code. I won't be going through all those internal details because it's basically the same concept, only used in different scenario. But ultimately, we just change the thread constructor to call some different methods. So what happens now is when we do execute this thread here, the constructor we are calling here is not the regular .NET thread constructor, but our custom constructor, which is actually this method. And you can see that not only our application survived the crash, so printed out, but also we printed that, hey, we are handling the exception, which wasn't handled at all. So this is another thing which we can do. And the last thing I would like to show you, because we are slowly running out of time, is how to handle Stack Overflow exception in .NET. So the Stack Overflow exception is actually a very nasty situation. Why is that? Because by default, when it happens, it kills your application immediately. You have no way to be notified about the exception. You have no way to handle it at all, which is very nasty, because imagine that you are running unit tests and one of your tests is actually throwing a Stack Overflow exception. So this Stack Overflow exception takes down your whole testing scenario, testing session, and basically kills the application. So no other tests are being executed. This is definitely not what we would like to do. So I won't be going into much of the details what is happening here. What I will explain to you is the general concept. So we would like to use the vectored exception handler. So we would like to introduce a thing from WinAPI, which is like a global exception handler when an exception on the CPU level appears. So because Stack Overflow exception is something that CPU throws on you, this vectored exception handler is capable of handling it. So what we need to do next is, the idea is we do the set jump long jump approach. Before calling a method generating Stack Overflow exception, we would like to save all the registers, save the state of our application, so we can later restore it when the exception happens. So what we start with is we store the registers, ESP, EBP, ESI, yada, yada. We store them in the helper array. Then we call the method called doWork, which is throwing the Stack Overflow exception, and ultimately we will be just cleaning up. So what is happening in the doWork method? Let me just find the doWork method. The doWork method, what it does is it basically spins forever calling recursively doWork, which ultimately throws the Stack Overflow exception, okay? When this Stack Overflow exception is being thrown in this line, the handler for vectored exception handler is being called, and we can extract the exception code from the CPU exception being thrown. We compare this exception code with the CPU flag, hey, is this Stack Overflow exception? And if it is so, then we use this array which we stored on the side with these registers, which we saved before calling the doWork method. We restore all these registers and ultimately tell the operating system, hey, it's perfectly fine to actually continue. We believe this exception is handled now. CPU is very lenient in this way. It just steps in, restores all the registers, and moves on. And in our case, the Stack Overflow exception not only did not crash our application, but also allowed us to safely continue. So this is yet another hack we can actually do with all these things under the hood. And I believe this is the last demo for today. The other things I will skip because we do not have enough time to go through all of them. Before answering a couple questions I can see on the chat, let's actually wrap up quickly. Summary, when it comes to hijacking all these things in C#, just keep in mind that ultimately it's just a bunch of bytes. You can take a bunch of bytes and use them any way you like. You need to understand CPU architecture, your operating system, your calling conventions. You need to understand plenty of things around. But once you know that, well, it's all safe. It's all just a bytes you can execute. Now the Q&A. Okay, the question is, do you think it's legit to use these hacks in legacy or larger projects? The answer is, if you don't know what I'm talking about here and all of this is new for you, then probably it's not safe because it may crash your application easily. But once you know all these things, well, I'm using these hacks for 4 years now in production applications, and they just work because, well, at the very end of the day, it must work. It's just a piece of conception here and there. That's all. Moving to other question. How did you learn these things? Is there a tactic you can apply to find such things? This one question I will answer with the reference slide. I will show you a couple books and articles you can read to start your journey in this thingy. And the other question is, what is performance of the code in comparison with normally compiled code? That's a very good question. When you compare the performance, in theory, you can be faster with the machine code you generate manually because you skip all the .NET checks which are there at the very end. But at the same time, because just-in-time compiler knows how to actually optimize your code, it may be that your code is slower. I encourage you to take a look at my other talk, which is called Custom Memory Management in .NET, where I actually re-implement a list of T, which is faster than the .NET list of T built-in type in terms of adding elements, but is slower in terms of iterating through the elements. So I highly encourage you to take a look at that. So the answer to this question is, what is the performance of the code? It can be better, it can be worse, depending on the situation. Let me go through these questions once again. I do not see any other questions. I'd like to thank you for all the positive comments you are pasting in the chat. And now, before we quickly wrap up, a couple references and answering this question, how to learn all these things. When it comes to books, I highly encourage you to take a look at these ones. Going from highest low level to the lowest low level, well, generally you can start with CLR via C#, and then you need to actually dive deeper into Windows operating system, in the user land, into kernel mode, into Windows internals, into drivers, into all these things. If you would like to start touching these things and looking at them like with a little like UI, let's say, there are two fantastic books by Mario Hewart, the Advanced .NET Debugging and Advanced Windows Debugging. And I do believe there are also plural site courses with same titles, so you can just watch the videos. And if you'd like to, if you are interested in things about the general listening or reading about fancy stuff like this, there is a great blog called The Old New Thing by Raymond Chen, who works at Microsoft. If you'd like to learn about these things I've shown you today a little more, I encourage you to take a look at my blogs. Here are a couple links where I post about all these things I've shown you today. And being all of that said, I think it's time to wrap it up. My name is Adam Furman, and I'd like to thank you for attending this talk. I hope you liked it. Hope you enjoyed it. Thank you.
Thank you, Adam. I think it was really a very, very well talk. I think the audience enjoyed it. You can see it from the feedback in the Q&A tool. I also see it on the YouTube chat. So thank you so much for joining us. You can actually follow Adam on Twitter as well. I'm sure he will be also happy to help you there and maybe answer some questions. We are moving on with the program. So Adam, thank you very much. I hope to have you in the future again as a speaker for maybe one of the upcoming topic days when the topic suits. So
happy to be here again. Thank you again. It was a pleasure being here.
Thanks. Bye-bye.
Bye.
Yeah, as I said, we are moving on with the next session. It will start in 10 minutes. So again, if you are coffee addict, get a coffee or whatever you want. The next talk will be about Blazor and Azure functions for serverless websites delivered by Menaka. So happy to see you again in a couple of minutes.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to 130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Welcome back, everyone. Thanks for staying in the live stream. So we are moving ahead with our last session of today. Welcome, Menaka. Thank you very much for joining us. How are you today?
Thanks for an invite. Really happy to be a speaker again.
Perfect. Menaka, tell me where are you joining us from and what will we learn from you today?
Today is completely about how we are going to work with a Blazor as well as with Azure function in serverless concept. And today we are just going to see how we can able to work together as a front-end developer as well as a back-end developer with the Blazor, WebAssembly and all other concepts.
Perfect. Thank you very much. So the stage is yours.
Live.
Yes. What today's session is all about Blazor and Azure function for a serverless website. So before getting into the title of Blazor and Azure function, let's get for separate concepts of each and everything. So why Blazor comes and what's the purpose of integrating with Azure function? So as a backend developer, as a C# developer, it is quite easy to work with the front end, which is already compatible with the C#. So from this concept, the Blazor comes into an action. So whoever been working as a backend as a C# developer, they can be easily adapt to the front end technology. Even it have a lot of pros and cons. For example, there are a lot of cons been there before, like either the Blazor supports the production, or is it good to use the Blazor for an EDA application. There are a lot of cons, but after .NET 5 release, which has happened before May, this all the cons been is removed, and Blazor is now super productively supporting for production environment. So today we are going to see, without disturbing the server, how we can able to work with the Blazor application by using our storage account along with integrating with Azure function. So here the Azure function concept, what I am using is for the usage of API instead of Azure function. Some cases you want to fetch some data from the database. In this case, what I can do without a server. So all this concept we are going to see in today's session. So the next slide, which is going is, okay, this is about myself. I'm currently working as a senior programmer. I'm a Azure and .NET certified professional. So for any doubts and clarification, you can reach me via this in Medium. So what today we are going to discuss is types of Blazor hosting, standard web architecture, serverless web architecture, and how we are going to consume our Azure function in Blazor app and hosting our Blazor app in our storage account. So all these concepts are being one beyond another or related to each other. So getting into the topic, what we are going to discuss today needs the basic. So I took the topic from the basics of hosting the Blazor. So either it can be hosted via server app or with WebAssembly app. So what is the usage of server app and what is the difference between the server app and WebAssembly app? So whenever you are creating any application and you are disturbing your server and you are hosting, then it will be probably under server app. So in browser in itself, you are creating, for example, if it is an Angular application, everything will be happen in your browser end. All the dependency, all the DLL will be downloaded in your browser end. So all these things will be happen in your WebAssembly app. So you can able to host any kind. For example, you want probably your server application which need to run from your backend C# code to a front end Blazor. You can probably go with the traditional architecture of server application hosting. Or I need my application to behave like my single page application. So I need everything to be already happen in my client end or browser end. So I can go with my WebAssembly app hosting. So all this depend upon our requirement. You can able to choose what kind of hosting you need as per your client requirement. So getting into the standard web architecture, everything, for example, my application have index.html, cshtml, or any other things, my app code assets all being fetched from the server. So whenever a user wants anything, he need to get to the server to get anything, whichever all the dependency things from my server. So in this case, it is okay, because a single user, I need things from my server, I can able to use that. In some cases, I have a multiple list of user in multiple zones. Think about creating a server, even it is a VM. What about my cost consumption? Even if we go with the app service also, what about my cost consumption, or what about my storage consumption? So lot of things, my throughput, latency, lot of things I need to consider here. So then think about, in same case, we need to fetch something from a database. So the traveling part from the user to server and database are consider it as a triangle. The traveling path, time consumption, and the functionality oriented stuffs, which will take lot of time, as well as the production ready application if you host somewhere. And think about the enterprise based application, what about the cost it will consume. So to minimize the cost consumption, to make our production application with very less cost, as well as the less storage consumption in all other functionality, as well as performance stability, to make it available. So we are getting into the serverless web architecture. So how the serverless web architecture work? I have my user account, storage account, which is created in an Azure, and the user is getting detail which is being stored in my storage account. So probably here we are not going to use any server. Instead of that, we are going to just create a storage account, and we are going to upload all the file which is necessary for loading my particular application, and from there we are going to fetch the detail that is containing like index.html or some other app code or riser or all the assets file, everything from the storage account. So here you may have some doubt. So okay, if it is a file that is rendering from the storage, it could be probably easy to get that file which is already stored in the storage account. So in case if I want to get some details, because I cannot give every credential or everything which is very sensitive in my storage account. So in some cases, I want to keep some credential which is highly secure, or in some cases, I really want to use the database. So what I can do in this case for the serverless architecture, to make available of all the things which I have said before, for example, credentials and security, and as well as to make your database connection to be established between your application. To make all this thing possible in your serverless architecture, Azure function comes into an action. So what is the role of this Azure function in this platform? Because we are using Azure function, so we just need to understand what is the main use of this Azure function. So here what the Azure function does is, here the Azure function will act as an API to get a value from your database. So it will not like a usual server application which will be standalone and it will be always on or always off. So here it will act as a trigger. So whenever you need, your API will get a detail from your database and it will return to your storage account. From your storage account, the user can able to access the detail which he need for his application. So this is quite easy, as well as I said before, the time, performance, functionality wise, cost wise, it is very effective. And this is how we are going to work together with Blazor as well as with the Azure function. So this is very basic of architecture oriental idea, because we need to understand how this normal web architecture as well as the serverless web architecture works. So from this concept, if we are going with the demo session, we will get into the greater insights of how actually all the things being held up in our browser. So let's get into the actual hosting environment. So before I just need to create some storage account, which is probably what we usually do. So after creating a storage account, for example, before we will work with even if we create a storage account, we will probably use for storage which is related to blob, because usually for a blob purpose, we will get into the container where we create a folders and we will save files inside the blob. So, but we will rarely notice this place static website. So this is static website is the place which we need to host our Blazor in our Azure environment. So after creating a storage account, just navigate to the place static website and just enable your static website. So this is your step number 2. So you can please consider your primary endpoint as well as the secondary endpoint, which I will say after showing the code. So here you can see the index document name as well as the error document path. So this document name as well as the error document path is usually you need to set up page which need to load when your URL get clicked. So you need to give the page which you need to show in your browser as an index. So this is a file which will be loaded when your browser loads. So error document path is usually the error file whenever error get originated from your code. So other primary endpoint and secondary endpoint which I will show in a code. So let's get into next slide. So after getting all the stuff and giving a primary endpoint and secondary endpoint, we will get a path name like a web. So $web. So what is this $web holds and where are these primary endpoints, secondary endpoints are originated? So all this we'll discuss in demo. So I just created a simple Blazor application which I have integrated with the Azure function for easier understanding. So what I have did here is I just created an application and then I hosted this in Azure. So this is where I have given in my, let me show from my storage account. So this is the storage account which I have created, and after that I have said like static website. This is a place where we need to invade. When we create a static website, there will not be a file, it will not be defaultly enabled. You need to just enable and you need to add your endpoints. So this is an endpoint. So this is my second endpoint. This is which I have hosted in Azure, and then I can able to add it in my endpoint, either in a primary endpoint as well as in my secondary endpoint. So after that, this is a file which I want to load in as when my browser get loaded. Once after this, where I need to navigate is, I just need to navigate to the container. In my container, I will have a web. This will not get generated until you given your primary endpoint and the secondary endpoint. So once after that, you can navigate to web. In this web, you have an option to directly upload your files. So when you are publishing your application via Visual Studio, it is very easy to get the downloadable file. So you can use that file and you can directly upload here. So once you upload it, you can able to view all the things which you need from your storage account. So if we come back to the slide, you can understand here now where I have said like the files which is fetching from your storage account. So these all are the files what we have added in our storage account. So once after this, you can able to view this file. So everything is done. Now when you run this application by giving the endpoint or either from your Visual Studio also, not a problem. For example, I'm just going back here. Let me check. So it will take some time to load. It's getting loaded. So let's see Azure function till it is getting loaded, because it will take some time. Yes. So after that, you can able to view this application directly in your browser. So this is what the Blazor application which we need to render from the serverless architecture. So all the files which I needed to be loaded from my serverless been already loaded from my storage account. So let's get into the second topic of Azure function. So as I said, like we need some details which need to be get from the database, or we need some credential to be get from DB, or for any trigger operation I need to perform Azure function. So how can I perform this? You can able to use this Azure function which will fetch the data. So for a simple case I use techies. In complicated case we can able to establish some triggers which is related to database or any other thing. So this is what I have done now currently. So what I have done from Azure end is, here I just created a function. So I just created a function here. So once after the function is created, I just going with this, with the trigger. In the trigger, once you navigate to code and test, you can able to see this line of code where it is like a required query. So this is the value which been passing from the code end. I will show you in the code. So this thing and the response message. So here you will get a doubt, like I have a function which is already been run in my Azure. So how the integration take part? So here to make this work easier, you will get a default integration URL like this. So you can able to integrate this with your web app, Blazor app. So by means of a single line of code, here I'm giving a hard-coded value, but usually some cases we need to do all other activity by fetching data from somewhere else, anywhere. So here for a demo, I use this hard-coded value. So by giving this, you get a get string async method. You can give this function URL. So once after it is done, you can able to perform the activities what you have seen in my browser. So everything related with the Blazor, as well as with the serverless, as well as how to use the storage account, this all been seen. So troubleshooting in, so once we are designing a Blazor with the serverless architecture, we have to face some of the troubleshoot. So to make, I just saying, so you whenever you are integrating Azure function, you will always face the cross integration issue, because you already know, like whenever it is not for a Azure function, whenever we are going with any platform to platform integration, we will have cross integration issue. So to fix this cross integration issue, you can navigate to cross, and you can see these all are my allowed origin. So you can set your allowed origin whenever it is running in your local host, you can set in a local host, and for your web app you can give the allowed origin here. So this is one of the fix. In some cases it will work without giving this cross origin in some cases, but in many cases it will throw an error because of this cross integration issue. And the second most thing whenever you are developing here is, you will get an error whenever you are going with a Visual Studio 2019. You will get a normal Blazor error because of your target framework. So kindly check your target framework and make, this is a common error which I have said before. So make your target framework as .NET Standard 2.1, and once after it is done, you will get another error which is very common when you are creating or running your first time you are creating a Blazor application in your system. That is like, you need to set the bound field tag to false. So this is also another troubleshooting. So if it is in your code, sometime if you are creating by means of older versions of .NET Core, that is not 3.1, if you are going with the downgraded version, you will have a .cs proj file. So just remove that field, or you can go with setting that field to true by default. So that will also help to fix these common issues. So once after this, the another issue you will get here is, whenever you are uploading your file, make sure the value should be what you given in here is like, in case if you are developing in .cs HTML, in most of the case what we will do is, we have our project currently in .cs HTML, or in our CS project in Razor views we will have a .html. So make sure the value which you are giving here, the index value, should be given correctly in your application where we will use to define the static website, because this is the index document which been loaded in your browser. So if you have been pointed out some of the value which is not presented in your upload document, this will probably throw an error, the document is not exit, because it is not exit in your project. So these all are the ways how you can able to manage or maintain your Blazor in your serverless architecture. So this is how this is like many people will ask a question like either Blazor is production ready. Yes, you can able to use in production, as I suggest before. After .NET 5 release, they have modified lot of features to make it production ready. So working together as a .NET as a backend developer with the Blazor is quite easy. So and it is very useful in current scenario. So this is all about today's session. So let's go with doubts, questions now. So one more thing to add on is like we cannot able to globally catch all the unhandled error in our Blazor single page application. Currently, this is not possible. So every component must be deal with the handling its own error. That is one of the cons on today's Blazor what we have discussed. So if you want, you can go with you can use any inherit for method, and you can use a traditional try and catch approach to catch your global errors. So that is also one of the cons which need to be considered while we are working with our Blazor. Okay.
Okay, thank you very much, Menaka, for this great talk. So there is 2 or 3 questions. Let's jump to that. So first question is, how do you set content security policy or apply URL rewrite rules for static client apps?
Once again, please, the question.
So once again the question, so how do you set content security policy or apply URL rewrite rules for static client apps?
Can you please repeat it?
Again? Okay, let's break the question apart in 2 questions. So how do how do you apply URL rewrite rules for static client apps?
Okay. Usually, this is asked before the content security. You can either include anything like a style sheet or anything, but for a Blazor here, you can use a separate plugin. So either you can use in a meta tags or you can either use a URL. It's like a I will show in my code. Usually for a script end, we will use to meta tags to prevent the cross-site scripting mostly. In a Blazor end also we will traditionally follow the same thing what we will use. Base URL or we will use all blocked, all mixed content like that stuff we will use to prevent the cross-site scripting, which is called like a content security policy in Blazor.
Okay. And next question, how do you secure Blazor apps?
Usually the content security policy is one of the way of securing your application from cross-site scripting. We said before we meta tags for apply policies by means of giving a separate meta tag for securing that. Where you need to give the content security policy and content. Inside the content, you can give all like a base URL self, or you can able to give anything which is related to block or secure. So there is one thing like upgrade insecure request. So within that meta tag, you can give. So this is how we will use to secure all the things in our Blazor.
Okay, thank you. So this was already the last question. Menaka, thank you so much for joining us. I think the audience has also enjoyed it. I hope to have you soon as a speaker again. So thank you very much.
Thank you, team.
Bye-bye and have a nice evening.
Thank you.
Okay, with that was our last session for today. I hope you enjoyed it. I think that we have four really cool presentations and that we can take something from it. So our next event will actually be the WeAreDevelopers Live Days, taking place in less than 3 weeks actually. You can find it on wearedevelopers.com/live. The registration will open very soon. The topics that we will cover will be a lot about front-end. We will have a lot about Angular talks. We will cover some native script topics. We will talk about micro frontends. We will also talk about reactive applications, so looking forward to that as well. So stay tuned, register your account on wearedevelopers.com or subscribe to our newsletter so that you get notified as soon as the registration opens. With that said, last thing but not least, if you are scanning the market for jobs or if you are looking for a job actively, you also can visit wearedevelopers.com and see what's there on the European market. Maybe there is also something in for you. With that said, I wish you all a very nice evening and stay safe and stay healthy. Goodbye from my side. Bye-bye.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.